wonder what a flying car looks like and how it works? Or are you interested in pursuing a career in STEM but just don't know where to start? Or are you just looking for a meaningful way to spend your holiday? Learn from some of the best in the aviation industry as they share their amazing career and the exciting experiences that they have. Explore with innovators and entrepreneurs as they come up with exciting technologies to revolutionize the field. And hear from educators who bring science to life through experiential learning. Aspire Week is here to inspire you. Join us online from 14th to 20th June. See you soon.
Hello and welcome to Aspire Week, where we explore flying cars, innovation and technology, and careers within the aerospace industry. In this session, we have Mr. Hozefa Aziz Singapore Wala, founder and CEO of Duck Learning. Hozefa, welcome to the show.
Thank you so much, Johnson. Great to be here.
Hozefa, you're a STEM trainer with many years of experience and a certified STEM teacher trainer from the LEGO Education Academy in Denmark. How do you connect LEGO to coding, to flying planes and rockets?
No, that's a very good question. Well, ever since Lego was the Lego brick was invented almost 60 years ago, I think it has inspired many inventors to actually start the whole making process. Before that, there were very few toys that had a system of putting things together. So Lego actually enabled, with its patented building system, it enabled kids to start thinking about building new things, coming up with new ideas and stuff. So in a sense, the whole maker movement was pretty much started back then. And that allowed students to think further, to think about new ideas and stuff, and venture into fields such as aerospace and build the inventions that we take for granted today.
And how do you apply that to flying planes and rockets?
So I think when we use Lego, many times we use it to prototype. For example, just to give you an example, Lego is something that you can take out and put back very easily. So if you want like build a new rocket or something, you can build up the different of the rocket and see whether what works and what doesn't.
Okay.
Yeah.
Okay, and then if it's wrong, you can just unassemble it and assemble it back up again.
Exactly.
Interesting. I'm sure our audience is looking forward to hear more and learn more from your experiences. I shall now leave you to share more, and we'll be back with you after your presentation.
Thank you. So just give me a quick second to share my screen. All right. Well, once again, everybody, thank you for having me here today, and thank you for attending this talk. I'm going to talk a little bit about coding to fly. And how coding and programming has actually helped us in our journey into the sky and even then into the stars. So as Johnson had mentioned just previously, we have been, I've been using Lego to train STEM for the last 15 years or so. And one of the main areas that Lego education has actually been very good at is teaching robotics and coding inside the classroom. So almost 20 years ago, they came up with the very first educational robot to hit schools called the Mindstorms RCX. Some of you may remember. And then they came up with the NXT EV3 and now the Spike Prime. And that actually enabled lots of students to actually learn about robotics, automation, and coding right inside the classroom. And as I mentioned earlier, using the Lego system of building. So it was easy to prototype. You didn't have to weld things together, screw things together. You just snap it together using Lego Education's system of building. And you can test, try, prototype, and see what works and what doesn't. And similarly with the coding, it also allowed us to actually build. It allowed us to code the robot in different ways, see what works, what doesn't. So today I'm going to talk a little bit about how coding has developed over the years, and especially in the area of aviation and space. How has coding actually helped us reach for the skies? So I don't know if many of you actually know what drawing this is. This is actually a drawing of Leonardo da Vinci's flying machine. And in many ways, Leonardo da Vinci was one of the very early pioneers of this area that we call STEAM today: science, technology, engineering, arts, and mathematics. Because not only was he a renowned painter, not only was he a renowned artist, but he was also at the same time a very good inventor, and he dabbled very much in the sciences. So he came up with an early prototype for the flying machine. Now, many of you may ask, okay, so what does this have to do with coding? Right? What part of this had a microchip inside and everything? And in many ways, Leonardo da Vinci was actually one of the pioneers of computational thinking, using problem-solving techniques that we naturally would use when we are coding. For example, algorithmic thinking when designing many of his inventions. Of course, the flying machine, didn't quite take off. Sorry for the pun, but it led to many inventors in later years thinking about the techniques that he used, the aerodynamic principles that he used, the algorithmic thinking that he used to actually implement in their own inventions later. And this is actually the very first aeroplane. I think that many of you may know these two gentlemen that are standing there. They're called the Wright brothers. They developed the very first aeroplane that you can see over here. An aeroplane that was motorized, not just a glider. So the two brothers, I can't quite remember their names, but the famous story is that both of them invented this, but they both wanted to be the first person to fly the plane, to be known in history as the first person to actually fly an aeroplane. But the aeroplane could only support one person, so they both flipped a coin, and the person who got on the plane was one of the brothers, and he flew the plane. But when the plane landed, they thought about how it would get off. Get off the ground and fly. They didn't think too much about the landing part, and the poor fellow not so poor because he got to be the first human ever to fly in an aeroplane, but he did fall down and break his leg. So that was unfortunate. But again, over here, the thinking about the systems involved, how the aeroplane would take off, how we would actually get into the sky, how we would move, is actually all influenced by computational thinking, which I will talk about in a bit later. Now, of course, from the Wright brothers, the aeroplane where the guy had to lie down on the lower wing and control the plane. Now, this is the cockpit of a modern Boeing plane. very, very different, lots of software running different systems. And many people would say the plane literally flies itself. Now, going directly into coding, I'd actually like to introduce the very first, one of the pioneers in aviation coding. Her name is Margaret Hamilton. Okay, and she was actually she's actually a researcher, or was a researcher in MIT, and NASA actually got a lot of researchers from MIT to work together with their own engineers for the Apollo missions. And as you all know, the Apollo missions are actually the ones that that NASA wanted to land on the moon and find out a lot more about what's going on, on our very own moon. So what she is standing next to is actually a whole stack of code, right? So this code actually is, so all of these papers over here actually contain the software that she and her team, she was leading the team, that her team developed to actually run the Apollo 11 mission. Okay, so the whole software back then, it had to be typed out on a large manuscript and everything, put manually into a computer. The computer would run the program, and this was the manuscript for Apollo. This was the whole software, as you can see, the whole stack of papers over here. This was the whole software that actually ran the very first moon landing by Apollo 11. Okay, and all of you know the story over there that Neil Armstrong, he's the one that we usually remember when we talk about Apollo 11, that he was the first man to set foot on the moon. One small step for man, one giant leap for mankind. While mankind was up on the moon, womankind was actually the one helping them out. So you know what they say, behind every success man, there's a woman. So this is the woman that actually was making sure the success happened. And when President Obama, during his term in the White House, he actually awarded her the Presidential Medal of Freedom. So let's talk a little bit more about what she did coding the Apollo 11 mission. Okay, so the onboard flight software, Hamilton was the one who actually was leading the MIT team working with NASA, and she led the effort to build the onboard flight software. So one of the main things, one of the main issues that they would face is that the software actually would get a huge amount of information. I mean, just imagine, going to the moon, all the kind of information that the computers would have to kind of process from all of the different types of sensors. And what was the main achievement here was enabling the computer to figure out which of the multiple processes it had to do was the most important. So what was the most important thing that we have to do right now? Otherwise, now just imagine this computer was back in the 1960s, where 5 megabytes of information would require a whole room to store. So there was this massive computer on board. Although so massive, it could only hold that, only process that much information. So one of the main things that Hamilton actually did was solve this problem, which got rid of the lesser priority jobs and kept the higher priority jobs, so that the whole system can focus on the task at hand. Now, of course, when everything goes well, the computers work back in the 1960s. Okay. Now, Michio Kaku, okay, he is a very famous physicist and popular author. Okay, said that today your cell phone has more computer power than all of NASA back in 1969 when it placed 2 astronauts on the moon. So just imagine that the mobile phone that you're having right now, many people have iPhone 12 or Samsung S20, 22, and all of that. But one of the main things is that this handphone that you're holding right now had more computer power that was running the whole Apollo mission at that time. That means that literally, if you went back in time and you gave them this mobile phone, they'll be like, oh my goodness, what is this amazing invention? Let's just plug it in and your mobile phone could happily, bring people to the moon and back. But that was because of the limitations of technology. The scientists could not use the conventional computers. They had to use an even more powerful computer, okay? And that's where the coding powers came in. That even more important computer, or rather more powerful computer, was the human brain, okay? So, sorry, this is comparing the mobile phone of now to this is actually the onboard computer on Apollo 11, which was before it was installed in the spacecraft. So now the human brain showed how powerful it was, okay, in a less fortunate Apollo mission. And all of you may know this Apollo mission by the name of the movie based on it called Apollo 13. And when Apollo 13, all of you know the story where it was supposed to go and land on the moon, but it never made it there. And because there was an explosion shortly after takeoff, and they had to then come back and they had to all run into the lunar module and somehow use the lunar module to bring themselves back to Earth. So over here, this is actually not the actual astronaut; it's the actor lah. Okay, so there's this amazing part in the movie, which is actually what actually happened in real life, where the astronaut would start getting instructions and information from the ground, from the NASA command center in Houston. Houston, we have a problem. So they started getting information from there, and this is the actual manual card. You see this manual card he's writing on. So this is the actual manual card which is preserved, where he started doing all the different types of calculations, and there are many manual cards after that as well. It's known as the famous page 29, okay, which was recently put on auction. Unfortunately, I didn't have that much money to bid for it, but it was put on auction, sold at a record price, because it is, imagine the number of calculations that have to go into redefining the mission. The computer could not do it. You had to redefine the whole mission, use the lunar module, okay, that's at the top of the spaceship for something that it was not meant for, and come back and turn the trajectory and come back to Earth into a specific landing spot. Just imagine that all the number of calculations while the oxygen is running out, while you are worrying for your life, for your family, everything, as you are stuck in space. Okay, so it is truly remarkable that engineers were trained to such an extent that they used the most powerful computer that they had. And of course, all of this could be said to be a type of coding, right? Because they were solving problems algorithmically. So the question that I put to you today is that if our phones are so much more powerful than the computers that put humanity on the moon, and they are, then why are we just staring at Instagram all day? Most of us nowadays, when we go on the bus or MRT, the whole journey, we'll just see the person looking at the phone. Either watching a movie or Instagram or Facebook or TikTok, or using it to record a fight that's going on in the MRT train. But computation is the means; it's not the end. We cannot say, okay, our computer is so powerful. This is where we want to end up, and that's. Computation has to be the means to something better, to a higher plane of existence, to something that we want to aspire to. So let's look at where computational thinking and coding is at the moment in the world. Okay, so we're looking at the World Economic Forum jobs report, and this was in 2018. Please know that everything accelerated by almost 5 years during the pandemic. Okay, the role of technology. So, what are the top 10 emerging? What are the top 10 emerging roles? Data analysis and scientists, coding very important. AI and machine learning specialists, coding very important. General and operations managers. I can tell you that as more and more robots take over, coding is going to be very, very important over there. Software and applications developers and analysis, don't know coding, not going to work for you. Okay. Sales and marketing professionals, which used to be right at the top, are now at number 5. Okay. And sales and marketing professionals more and more need to know the basics of coding because they're using softwares. They are depending more and more on big data, and they're using software which requires a lot of background programming, right? So, for example, if they use CRM, customer relationship management software, each company has its own type of sales process, its own type of sales, unique sales strategy and everything, and they have to adapt the software to suit their needs, not suit their needs, suit their processes to the software. So they have to learn how to program it. Then big data specialists, digital transformation specialists, new technology specialists, all these require more than just a basic level of coding. Now let's look at the Future of Jobs Report 2020 by the WEF, where COVID-19 is pushing companies. 83% companies are going to scale remote working. That means that just like what I'm doing right now, talking to you from my home, okay, more and more companies are going to require, even after COVID-19, realize that remote work works, okay? So when remote work works, you know that remote work is only made possible by technology. It is only made possible by the use of things like Zoom, the use of things like proper speakers, proper teleconferencing, using things like Microsoft Teams, Google Workspace to collaborate. Okay, 84% are going to accelerate digitization because they realize that digitization is helping to cut costs. The more things that are done digitally, the less things that have to be done physically that take up physical space. Okay, and 50% is going to accelerate automation. Okay, and why is that? Because when they realize that when people can't work in pandemic situations, they had to depend on machines. And when they started depending on machines, they say, hey, the machines are doing great work already. So I need to, so why don't I invest more inside the machines? So at the end of the day, the people who will survive this big transformation and thrive in this big transformation are the people who know how to control these machines, are the people who know how to live in this whole new digital environment. A few days ago, I made a post that last time we used to talk about digital natives, that, you know, people like us born in the 1980s are what I call digital migrants. We are migrating into the whole digital era. But digital natives, like the children being born today, going to P1, P2 today, they're the ones already born in the digital era. They're the digital natives. They were born into this whole environment. So their whole childhood was growing up with this. They didn't have to adapt to anything. But now we're talking about a new breed of people, those who are maybe all the way from 1 to 8 years old now. We call them the pandemic natives. Why? Because they all started their different stages of schooling in the pandemic. They know how to already use this digitization so easily. They know how to do this automation so easily. They are so aware of all of these tools that they can use to connect with their friends and everything that is already second nature. So these are the pandemic natives who will be more inclined towards coding, who will be more inclined to know what is behind the scenes in all of this digital transformation that's currently happening. And now we are stepping into what's called Industry 4.0. Okay, when Industry 1.0, 2.0, 3.0 was based on when factories first started, the coal revolution. Then we talk about the mass use of machines. Then we talk about computers coming in Industry 3.0. But now in this Industry 4.0, we're talking about technology taking the next step. For example, in AI, where we can have autonomous robots, big data and analytics, where machine learning comes in, simulators, we don't have to build the whole thing anymore. We can see computer simulations, augmented reality, system integrations, where systems can talk to each other that don't need to be humans in between to translate from one system to another. IoT, okay, becoming more and more important in this pandemic era, where you cannot track the things manually. You have to then use IoT to track all of it. One of the companies that I really admire in Singapore for being able to put in IoT so well into from everything from probably their production to the point of payment is Decathlon. So if you've ever gone to Decathlon, especially their lab in their sports lab in Kallang, okay, you will see what I mean. And cloud computing. Cloud computing has been one of the bedrocks of work during this pandemic. So when we talk about coding leads us to develop, when we say coding, okay, last time the big thing in coding was Java, JavaScript, C++. Now it's moved on to Python. We don't know what's the next step, what is the next big language. But the more important thing that we want to develop during coding, which I've been talking about since the beginning of the presentation, was computational thinking. And it is the computational thinking skills that we need to develop right now that will enable us to actually bring technology much further. So these are all concepts and approaches that a person needs to develop in order to do coding really well. So for example, in your concepts, you have logic, okay, predicting and analyzing, evaluation, algorithms, making steps and rules, patterns, spotting and using similarities. These are all green, these are all blue, they are in different categories. Decomposition, huge problem, we break it down into parts and solve each problem part by part. Abstraction, remember when I was talking about what's important and what's not at the beginning, what Hamilton was doing. So that was abstraction, removing all the unnecessary detail to focus on the problem at hand. Then these are the approaches: tinkering, changing different things to see what happens, creating. So as Johnson asked me earlier, how does Lego help you in STEAM and coding? Okay, so these are the ways. Okay, it helps you to change things to see what happens, create, designing and making, fixing errors, persevering, make sure that you go on to the end, don't just give up. Okay, and most importantly, collaborating, because it takes a team. Hamilton didn't do it by herself. She led a whole team of scientists from MIT and NASA to make the Apollo 11 mission successful. Now, another thing that has been going on since for the last couple of years is syntax versus graphics-based programming. So, what is syntax and graphics-based programming? Syntax programming is what you see at the top over here. Okay, all of these. Many people will call it mumbo jumbo. Okay, that comes from all you type out all of these different things. And you type out the language exactly as it's supposed to appear. But graphics-based programming, which is becoming more and more popular, is something like this, where all of this syntax is actually represented as graphics. And what you see is a systems view rather than just very linear view of what's happening, and you see a very systems view. Okay, and in this systems view, you are actually able to get non-syntax coders involved. So engineers who may not be so familiar with coding, scientists, okay, those who are doing maybe geological surveys and stuff, they are not so familiar with syntax coding, yet it is easier for them to learn graphics-based programming. So this kind of software, for example, by National Instruments, we have LabVIEW, which is a very famous automation software by National Instruments. Then you have MATLAB. Okay, all of these are industrial graphics-based programming platforms. So if you look at Curiosity rover on Mars, okay, this is the Curiosity rover. I'm sure all of you must have heard about it at some time or the other. A couple of years back, somewhere in, I think, 2017 or 2018, I had the opportunity to actually meet one of the scientists that worked on the team that runs the Curiosity rover on Mars. So basically, every day they have to decide what the Curiosity rover is going to do on Mars. And she was actually a scientist, but in which area? Geology. Okay, so she was interested in the rocks and everything over there, but she has to do the programming as well. So it is the graphics-based programming that actually allows all of these different scientists, the geologists, the physicists, the chemists, all to come together, okay, and work on the program together, okay, using graphics-based programming to use device as sophisticated as the Curiosity rover on Mars, millions of miles away, okay, to do the kind of experiments that they need to figure out what they want to figure out. I think many of you may have remembered the Red Bull Stratos jump, okay, where I forgot the name of the adventurer. He got into this capsule. This capsule was actually lifted by a balloon all the way up into the stratosphere, which is almost space. And he jumped from that capsule down in a parachute jump. It was the highest jump ever done by a human being. And you can see that at the stratosphere all the way down, there's no oxygen. So he has to literally dress as an astronaut before he jumps. This whole thing was actually maneuvered by LabVIEW. So the whole control system, the flight path, everything, bringing up, all of that was controlled by a graphics-based programming platform called LabVIEW. Now, the next step for aviation, and in many industries, but we are talking about aviation specifically because that's the topic of the day. So AI plays a very, very big role now in aviation. What is the difference between AI and the kind of coding that we've been doing? The kind of coding that we have been doing is a set of instructions. Okay, we are giving a set of instructions to a machine or a system to follow. Okay, and there's the decision making. All the decision making is done by us. That means we say, well, if you see green, you go left. If you see red, you go right. Okay, we've told it exactly what to do. However, artificial intelligence means that we allow the machine itself, the program itself, to evolve its own understanding of the world around it and make its own decisions. Okay, based on data, based on past experiences. Okay, so if you look at AI, is a very big area. Okay, so if you say AI, I know AI, that doesn't make sense. What is it in AI that you know? All right. So what a lot of people focus on when they mean AI, okay, so this is artificial intelligence. Then we have what's called machine learning. Excuse me. Within the confines of AI, we have machine learning. So machine learning is when the machine itself uses statistical methods, okay, from maybe data that has been input into it from previously, and it learns from the data and from its own experiences, and then adapts its behavior to become better based on that data. Deep learning is actually a subset of machine learning, which uses what we call neural networks, multi-layer neural networks, and it's almost based on the architecture of the human brain. where it allows decision making in very complex situations. So if you look at artificial intelligence, okay, I was talking about machine learning, which does predictive analytics, deep learning, speech, text to speech, speech to text, which is something that we already have on our mobile phones. Okay, image recognition, language processing, planning and optimization, robotics. So what kind of applications does this have in aerospace? So that time is already here. So if you look at Airbus, everyone knows Airbus, it's a European consortium, and EHang, I hope I pronounced that correctly, a Chinese company making passenger autonomous aerial vehicles for urban air mobility. So both of them are developing AI technology together for intelligent navigation. So these are actual drones, okay, which you can support humans, okay, they can sit inside, and there's no driver. You press a button, say, okay, maybe I'm at City Hall right now, so I put my bags inside. I press a button, say I want to go to the airport. Then it will tell you, okay, it costs $15. You tap your EasyLink card. Then it will start flying by itself and will go to the airport and drop you at the designated drop-off point. Okay. Based on wind conditions, based on other drones flying in the area, based on buildings, everything, it will make its own decision on how to go over there. It will just bring you there safely while you can watch maybe a 15-minute film on your way over there. Okay, so this is how AI is going to help us transform the aerospace industry in the future. And this is just talking about drones. Very soon, this could even come into aeroplanes. Okay, many of the aeroplanes in the future may not even have pilots anymore. They will just take off and land by machines, just transporting you there, right? So many of us will, well, if I've convinced you enough that coding is a very important aspect. So how do we take the first steps in coding? Many of us maybe don't know anything about coding. You know, what are the very first steps? So myself, I'm actually a molecular and cellular biologist by training. My degree was in molecular and cellular biology. So how did I start learning coding? So there are two platforms that I would like to introduce to you now, which are completely free for you to look at. One is Scratch 3.0 by MIT. Okay, you can just search for Scratch 3.0. It's a free account. There are many platforms which teach you how to use Scratch, and Scratch itself will show you how to do this graphics-based programming to create little games and videos and animations on its platform. The other one, if you have an iPad or an iPhone, you can actually use Apple Swift Playground. Apple Swift Playground is a very gamified environment which teaches you how to code, and it has step-by-step guidance as well. So it is it's actually quite good. Okay, that's all I have for you today. Okay, if you have any questions for me, you can drop me an email at hozefa@darklearning.com. And if not, thank you very much for your time.
Thanks, Hozefa. It was really interesting. I feel so empowered to know my iPhone has the potential to send astronauts to space. We are consolidating some of the questions right now. Let's just have a look. I find coding difficult to understand. Is there any tricks and tips that can help me make coding more understandable and easy?
So it's a good question. I also find coding quite hard to understand. What I would recommend is start small and be consistent. So, for example, some of the platforms that I showed just now, Scratch 3.0. Scratch itself, it can be a very powerful platform to do coding. Scratch can even code some robots. For example, the Lego Education robots can be even programmed by Scratch, and many other platforms as well, even Arduino. So try to focus on Scratch itself. Scratch is a graphics based, so you can it's easy to remember what you have been doing, because you are simulating more parts. You are using more parts of your brain, visual, auditory, and all of that. So it will actually help you to see it better. And because it's not linear, okay, it draws out like a map. Some people say like a mind map. It's actually closer to the way of learning that our brain is used to, or our brain is built for. So if you start simple, it will become easier, because then you are building the skills to help you develop more competency in more complicated areas of coding. Yeah.
So start simple, that's the key. I know coding is important, but have zero knowledge. Any advice on good books to read, or where should I start? I think where should I start, I think you touched on in your presentation. Any good books you can recommend, Hozefa?
I don't have any good books, unfortunately, to recommend, but I suggest that you just get your hands dirty. That's the best way to learn coding. Start off with Scratch 3.0, search for it, and I'm sure that you will have a very fun journey. You can also have a look at our website, ducklearning.com. We have some resources there as well that you can use. Yeah.
To pick up coding. Okay.
That's right.
What are your thoughts on the programming language Swift?
So just now I showed you what was called Swift Playground, which is not Swift itself, but it's a platform to start building up those computational skills. Swift is a very powerful platform, in my opinion, and I think that they have been trying to be very, very inclusive. They have invited many developers from around the world, Lego Education included, to allow Swift to actually program their platforms. So I know a lot of people who wouldn't say that they're very good at coding, but they started learning Swift and they've developed apps and all sorts of things with it. And I'm talking about from very young to very old. I know some associates who are in their 60s and they never learned coding before, and they started learning Swift and they developed apps for their own use. So I think it's a great programming language. It's a great platform, and if that's something that you want to explore, I would highly encourage you to go ahead with it.
And when you say that Swift is a good first programming language to learn, or do you have a recommendation on that?
If you want to go into directly into syntax coding, then yes, Swift is not a bad platform to jump into.
Okay. What are some different prototypes that you have made so far using Lego bricks?
What are the different prototypes? Well, I'm a father of two girls. Most of my work with Lego now is helping them build their prototypes. So I'm never one to stifle imagination. So we've had they've using Duplo bricks and the system bricks. They've built all sorts of things like on-the-go makeup parlor where you can sit down anywhere, open the suitcase, and the thing will do the makeup for you, everything at one go, and things like that. When the pandemic first started, before the circuit breaker, everyone was talking about don't touch anything, try not to touch things around you, but at the same time, use hand sanitizer. Then many companies don't have the automatic hand sanitizer, so difficult to use. So my colleagues and I, we thought about developing one using a robot where you just put the hand sanitizer inside, and then there's an ultrasonic sensor there. When you put your hand on top of the ultrasonic sensor, it automatically presses the dispenser and dispenses the hand sanitizer in your hand. So it became quite successful. A lot of my counterparts in other countries asked for a design, and they also built it themselves for their own office. So I thought it was quite a simple thing, but it turns out to be very useful.
Oh, there's really no limit to what you can do with Lego, right? Yeah, it's anything under the sun.
Just to share with you on this, in the Philippines at the beginning of the pandemic, there was a huge shortage of ventilators. And ventilators actually is not that difficult. It's not a very difficult design. You need to pump air to push air pressure into the lungs of the patient. So in the Philippines, our counterparts there work with a university. They had a lot of spare Lego sets. So they actually created ventilators using the Mindstorm set and actually helped to save a lot of lives over there. So like you said, there's no limits to something like Lego. And this was one of the prototypes they did, which was very, very successful. And they were given a national award by the vice president of the Philippines.
Fantastic. So not just to learn, but also save lives. Is there a risk of picking up a coding language which might become obsolete? Any advice on any one I should pick up?
This is same as asking me, is there a risk of buying a mobile phone which will become obsolete? Yes, it will. No matter what you buy now, will become obsolete. So no matter what programming language you take up now, will become obsolete. That's just the nature of technology, right? As things become better. That's why when I mentioned earlier, the more important thing is to pick up the skills behind which are behind coding, which is the computational thinking skills. So it's there are some basics. There will never be a program without algorithms, for example. So it is very important to get the skills. Don't root learn all of those things. Last time when you are doing Java and JavaScript, especially JavaScript, there will be those people who just know how to copy the script, put it into their HTML code, and then pretend that they did the whole thing by themselves. So basically, if I show them another language, they will not know how to do it. Yeah. Right. So similarly, focus on the skills behind it. Learn so that even when you change to another language, it is easy to pick it up. It's not that difficult. Even now, we deal with many different languages. So I started off with Scratch, but very soon I had to learn how to use MidCode lah. I need to use how to use this LabVIEW, MATLAB, and all of that. But once you know the fundamentals, you have the fundamental skills, you can easily apply it to many different areas.
Okay, and this goes back to your earlier point, just get started and get your hands dirty first.
Right. That's right.
Do we have more questions? Okay, I just obtained my certification in Python in order to stay relevant in aviation. What are some mini projects you can recommend?
Wow. Maybe this one, Johnson, you might be better at...
I'm a notebook for tech. But maybe we could take this question offline, and then we can identify the question, and then we can get back to the person who asked.
If I were to just put it in, one of my something that's quite that's quite the in thing now is synchronized flight with drones. So you see, even during the National Day Parade, there was a synchronized drone exhibit and everything. And I'm always fascinated by how you can synchronize drones so well in the air. I mean, it's like, on the land, it's one thing because you just go to a certain point. Air is like, how to synchronize it there? And I've been trying to do it myself with quite a bit of difficulty. So, it might be something that you might want to look into because might be high in demand as it gets more and more popular.
Drone synchronization. Okay, I hope that answers the question. Maybe we'll see some drone activity in the skies. And this will be the last question. If computers are becoming so powerful now, Would there be a day where human labor will eventually be rendered obsolete?
Have you watched the Terminator movie? Of course, we all must run and make sure that the robots never take over. No, I'm kidding. But um, the thing is that humans will never be obsolete, because I believe that I don't think humans can ever make anything that doesn't require human intervention. So the thing about would anyone become obsolete? Yes, we will become obsolete if the robots can do exactly the same job that we are doing right now. So that's why we must learn how to be the ones that bring in the innovation. We must always upgrade our skills. Okay, today you might say I'm a very good minutes taker. You know, I can take minutes very well inside a meeting, but tomorrow, you know, there's there's one program which some of my colleagues introduced to me, where you just add it as a into your Zoom meeting, and it takes down all of the everything that you say. So we actually don't need a minute taker anymore. We just have someone typing down everything. So you have to keep upgrading to make sure that we don't become obsolete. That is the way of the world right now. There's no two ways about it.
On that point, that was the last question. And Hozefa, I wanted to thank you once again for sharing your insights and thoughts with us today.
Thank you for
working with you again.
Rover Johnson. It was a pleasure.
Thank you. To the audience, if there's any more questions, please put them through to us on YouTube or social media, and we'll be happy to take them. We have a full day of activities today. So coming right up at 2:15, we have Mr. Rajashi Maiti, Materials Capability Acquisition Engineer at Rolls-Royce, and we will be discussing some of the groundbreaking and revolutionary innovations and technologies they are working on. So stay tuned. That will be at 2:15. And before we end, on the 1st of July, we have invited a very special guest on NASA astronaut, very special guest on the show, NASA astronaut Jeff Williams. So let's watch this highlight.
Standing by. And liftoff. Jeff Williams, Alexei Yovchin, and Oleg Skropochka launching to the International Space Station.
So if you have not already signed up, you'll be prompted to do so after this session. There is also a link to sign up in the chat. I'll see you then. So thank you all for being a great audience. Please give us your inputs on how you found the sessions. I will see you at 2:15. Bye-bye.